a mandatory system check. Please try your microphone. One more time.
Oh, one.
Yes, we can hear you. Please click something. Yes, we can click. And as always, this stage and the audience is yours. You can see your slides here. Applause, please.
Hello all. Today I will describe how we redesign, rebalance in our final latest version, Apache Ignite. And first of all, let me introduce myself. My name is Pyatkov Vladislav. I work at GridGain. Our product is based off Apache Ignite. It's a distributed database, and Apache Ignite is also a distributed database. And I have been working as a developer about 5 years in GridGain. And of course, I'm a contributor of Apache Ignite. And today, currently, we redesign the product and rebuild some internal features, Apache rebalance and replication. Today I will describe it, how we did it. And start from the several terms which I will use in the presentation. And first term is node. Node is a single server. It is a part of a distributed database. And when we see several servers, we think it communicates through the network. It is a cluster. Cluster, all the same terms as topology. It's a set of nodes. And of course, we use a distributed system to store a bunch of data. The data spread across the several nodes and divided by several tables. You can see 2 tables and one entry, and the entry spread across 3 nodes in several copies. Which the particular entry belong is determined by affinity function. It is an analytical function that's calculated locally and determined where the particular entry stored, which node the entry is stored. And more convenient to determine where the entry is stored using a set of entry. The set of entry is called a partition. And you see several partitions that are distributed in the storage. And of course, one partition contains not only one entry, but a set of entry. In this example, we see a third partition has a 5 entry in the storage. And of course, we should have several copies on one partition, and the copies called replicas. For the table 1, we have 2 replicas for each partition. You see it in, for example, for partition 2, we have copies in node 2 and node 3. And for the other table, we have another one replication factor. The replication factor is 3, and it means 3 copies of each entry stored in each node on the distributed database. And we're ready to describe a plan of the presentation. First of all, I will describe about data moving processes. There are rebalance and replication. Then I will describe behavior in a stable topology. There is no rebalance, but it required to deeper understand when I describe behavior when the topology, the distribution is changed. And the third part, I will describe what happens when distribution changed. And the first part of the third part, I will describe triggers of the changing distribution. It can be due to add node or remove node. I'll describe it later. And for this part, I will describe an algorithm which satisfies all requirements. It is a RAFT algorithm, and also I will describe their features. And the final part, I will make a conclusion. Start from a first point. It is data moving processes. There is 2 processes, and first is rebalance. Rebalance is a process on distributed database. It is a common process for distributed database, which has a purpose to distribute data as uniform as it possible. If you look at the slide on the left side, you see a cluster where the data distributed is not evenly. And then after the rebalance finished, we have the same cluster, but the data distributed as even as possible. And another one process is replication. Replication is also a process to distribute, to move data across all nodes. It is the purpose, but there is something different of rebalance. The difference is a purpose. Purpose of replication ensure consistency across all partition. When I said consistency, I mean identical copies. When we see in the picture, in the left side we have a writer. The person writes some data, and the other one person, after several minutes, reads the data. And the data should be read, which the data which was written should be read by another person. Thanks for the replication. The process make expectation of different person who use it through the different nodes as they think about as a single server database. And I want to describe about two approaches to the replication. And first approach based on entry transfer, and second one based on log transfer. There as well, we will propose about one partition has 3 replicas. And look at the first approach. Here we have a trigger of replication. The trigger is a user who executes some operation on distributed system, and when the operation is executed through the replica 1, the modification proposed to replica 2 and replica 3. There is a trigger. And when we look at the second one approach, all nodes, all replicas exchange their parts of log to make their replica consistently. It is the main difference of the both approach. The first one has a trigger, but another one has no trigger. Of course, the user modifies some data, but all modification proposed to some node asynchronously depends on the operation which executed by user. And the second one approach is typical for Ignite 3. It's a new version. But if you remember, the first one approach is typical for Ignite 2. It's a later one. And we're ready to describe a replication in a stable topology. Look at the slide. Here we have 2 replicas. The 2 replicas, the right one misses several updates, 3 updates, and other replica is actual. Actual replica sends 3 updates to the another one replica, and the updates applied to the log storage. And of course, when the update is applied, attached to the log storage, they should be applied to the internal state of the node. Of course, we will apply in order to log ID. And first of all, we will apply a record with the delete operation. This delete operation, then we apply with ID 5 update operation, and then insert operation. And here's the same replicas. We should understand here we will apply all updates serially. I mean, there is no interruption. If we have another one operation which will be executed when we apply an operation, the operation will have a higher log ID than that which we already have. We avoid of concurrency here. But we can't have another one situation. In this case, we have no all log records to send to another one another one node. And in this case, one way to do it is to send a snapshot to remote node. Of course, before apply the snapshot, we should clear the storage. This case always happens because the log is a structure that infinitely grows. And one time we achieve a space limitation and should truncate the log. And we always think when we use log replication, one time the logged node required a more log than we have. In this case, we send a snapshot, and before they apply the snapshot, we should remove all data from the logged node, and then just copy all data to the node that was logged. And the result the same. We achieve the purpose of replication, but here logged node have no any log because the replication happens based off snapshot. But of course, in this case, the node that was logged have another one log ID. It is required to further replication process. And the result is the same as before. We achieve the purpose of replication. And when we understand all of that, we are ready to move ahead and describe behavior when distribution and change it. First of all, I describe about the trigger of changing distribution. And the first trigger is removing node from topology. It can be happens due to, for example, hardware reason, when something trouble with the hardware and node go offline. In this case, just after the node removing from topology, we have all distribution across the two rest node. But there is a violation of replication factor, because not all partition has a two replica. We can find the partition which was in the node that disappear have no copies. And we should recalculate distribution and move some partition to recreate the partition in the rest of the nodes. When we recreate, of course, in a new distribution, data distributed uniformly and go to the replication level. If we choose one partition that's stored in node 3, we before in a old distribution we have a replication group for the partition contains node 1 and 3, and then we have a replication group contains node 1 and 2. In this case, we should to create another one replica in the node 2, and then look at the replication schema. We communicate between the node, we have communication, replication communication between the node 1 and node 2. In this case, of course, we use it replication, it's snapshot-based replication, because less probably to have all history on the node 1 to use a replication based off log records. And look at the another one trigger. It is the opposite one of previous. In this case, we have two nodes and add another one. The system administrator decided to add another one node and expand the cluster. In this case, we, in an old distribution across the 3 nodes, just after the node added, we have 2 copies for all partition. I mean, there is a replication factor is still there, but data distributed is not evenly. In this case, it is a trigger of rebalance, and we should recalculate distribution and move some partition to the node. Let's do it, and of course, after the recalculation distribution, the data become evenly distributed. And of course, look at the replication level, how we use replication for doing rebalance work. And in this case, we have a copies of partition before in node 1 and node 2. And then we have a copies on node 1 and node 3. And when we look at the replication diagram, we have interaction between node 1 and node 3 after recalculation distribution. It is a significant when we still not have any copies on node 2. It means when we switch to the new distribution in one time, we lose the copies on the node 2. Of course, it happens on a lot of other operations. And we should to have intermediate distributions that we have that we still have a copy on a node 2 until the copy on a node 3 become up to date. And we're ready to formulate points. Points to require to change distribution. And the first point, recalculating using new topology, new distribution in the new topology L when the circumstances is changed. After the recalculation, we should determine that partition whose replica should be moved to another node. Then build an intermediate distribution, and cluster will walk in an intermediate distribution until all replicas become up to date. And only when all replicas up to date, we're ready to switch a new distribution and continue working on it. And we're ready to describe a protocol. But before that, I deeply describe how should intermediate distribution can build. I will describe one situation when we lose all copies when we try to switch a new distribution in one time. Look at the diagram. There is 5 nodes and only 3 have a replication. In this case, we have an intent, because some circumstances changed, we have an intent to change a replication group for that partition from node 1 to 3 to node 4 and 5. And of course, we can do it only from the intermediate distribution. In this case, we use an intermediate distribution that contains all replicas. I mean, from 1 to 5. And at this time, we have a storage of this partition across all nodes. And when all the copies is become up to date, we're ready to switch to the new distribution and remove copies from nodes 1, 2, and 3, and continue working on it. And we describe a protocol that satisfies all requirements. It is a RAFT protocol. It's the common used protocol for this distributed system because it's based off log replication, and of course it supports updates, writes, read separation, and also the protocol allow to change a quorum or allow to change a replication group. And of course, the algorithm describes a situation when we have no log and can't use a snapshot to replication. But of course, the RAFT protocol based off consensus, that protocol reliable in case of split brain. What I mean, when we have a 3 nodes between these nodes, we have a replication based on RAFT. And one time we have a split brain problem. The problem divided the cluster of 2 parts. And all 2 parts is alive in some cases because it's a problem due to the network. The node 1 can be connect to node 2 and 3 and vice versa. In this case, we can process all operation only one part. I mean part which has a majority, which has a consensus. It is a part which contains node 2 and 3. For the part contains node 1, only way to restart, because the part can be process any operation. The part have no majority. Of course, there is a convenient for us when we have a cluster which can process our load after the split brain. But we have a limitation when we have a two-node cluster or two-node in replication group. In this case, we have a RAFT replication between the nodes. And then one time happens a split brain problem, and we have two nodes. Here, the two nodes can be any one of two parts of cluster can be processed data load, because no one have a majority. If you look at the one and two node cluster, majority of two, it is a two, and in this case, all nodes are alive, but can be processed all data. It is strange for a user who thought about who try to access the cluster. In this case, one user try to access, and here all nodes alive and all data is present in this node, but can be processed in operation because of the limitation of RAFT protocol. In this case, only way to restart all cluster and recover the network if you have in a cluster two-node replication. The problem can be solved by the protocol only the invitation of the system administrator. You think about the limitation and configure the cluster. And we're ready to make a conclusion. In the first part, I will describe it common technique, common processes for data movement and distributed database. Then I will I describe it a lock replication, and the lock replication help us using the lock replication for the rebalance purpose. We solve rebalance purpose to move data using replication. And of course, a replication based off a lock help us avoid of a problem of concurrency when we have a lot in the data, and in this time we have a replication from one node to another. I described it before. Of course, using replication based off a lock record is, in usual case, is more preferable than replication using a snapshot, because the lock replication in usual case required less space and less time when we replicate data from one node to another. And the RAFT protocol is satisfy all our requirements, but have a limitation. For example, two-node cluster. It is a challenge for RAFT to have two nodes. It's not the problem not resolved using a RAFT protocol. It is all which I want to say. I'm ready to a question. Thank you.
Thank you, thank you. And now goes your main challenge for this talk, to remember the best question to give our special prize. And now, first question, you're welcome.
Hello, thank you for interesting talk. Do you store a lookup table for affinity function results, or you calculate it in real time?
Oh, of course, the results should be cached if you require it to. You mean a static distribution? No, we have no static. It is possible way when we have a static distribution to use it all time when we change topology. But here in our product, we of course calculated in a specific circumstance. When we lose node, we calculated affinity function locally. It is an analytical function, I already said.
Okay, so you mean when RAFT protocol change detection by node list, you recalculate local function and know about which partition should be moved between nodes, yes?
Yeah, but I don't describe, I don't say it is bounded with RAFT protocol, because we have to another one protocol for discovery. it's based on another algorithm. How it's called?
Okay. Next question is which model?
Gossip, I remember.
So, okay. Next question: which model do you use to move partition between nodes? Pull or push model? When initiator node try to push partition to another node, or the destination node just pull partition from source node? Who is the initiator of partition move?
Which difference? Who is the initiator? Main difference it's about amount of data which we should transfer through the nodes. We can think initiator. All node is initiator because
when we have two nodes. One is initiator, which store source data, and destination node, which can't have data in this moment. And who will responsible to move data? Destination node, which will periodically pull data from source node, or initial node, which will push data periodically. So. Main
things, we have no push-pull algorithm. We don't think about it because all nodes have a current topology. All nodes think about circumstances. Each node can be recalculate affinity function and understand which node should to be has a replica. And the replica, when we create the replica, all based on RAFT protocol too. But of course, RAFT protocol used for this periodical message.
I think that implementation details can be discussed in our special discuss area. And now, while speaker is on the stage, we can seed our discussion with a question. I can see more hands. I can see more hands, please. You're welcome.
Thanks for your talk. Actually, I would like to ask about, you mentioned the Apache Ignite free, but I see it's still in beta stage. So what is your roadmap? And I think it will be ported to the GridGain also, right? So it's still in beta. I think it's not ready. So when is basically the roadmap? So when we can expect.
Another one word, why we create another one version?
No. So you mentioned the new protocol, it will be in Apache Ignite free, right?
Yeah.
So it's still in beta. So when we can expect, because we are using it, and when we can expect, do you know any dates when we can expect Apache Ignite free? Because, I mean, you mentioned it's new with rebalancing will be available for version 3.
Yeah.
It's version 3 of the protocol or version 3 of Apache Ignite?
Rebalance is not a protocol. Rebalance is a process. The process was on 2. But maybe you ask me which purpose to create another one protocol to
No. Actually, is it available now? What you described with new rebalancing mechanism? Is it available in current latest release of Apache Ignite?
In Ignite 3?
Okay, so because I thought you mentioned version 3,
yeah.
But Apache Ignite version 3 is still in beta. That's why I'm asking: is it version 3 specific release? I mean, or it's still it's available for current version? Okay, so it's.
Let me rephrase a question. I'm a small business and I use Apache Ignite for data storage. And I just visited your talk and I want to do the same RAFT rebalancing algorithm in my setup. What, as a small business, I need to do after your talk?
But you still understand that currently Ignite 3 in a beta version.
Yeah, I was asking this one. So when we can add, the dates, when we can have the stable version?
We think it will be about summer.
So we just need to wait half a year, test drive the beta version, and apply all the changes when version 3 is released. Please, next question.
I thank you for your performance. It was great and interesting. And I have a general question. It's about like cap theorem, right? Like consistency, availability, or partition tolerance, and about Apache Ignite. What do you focus more, like on availability and partition tolerance? Like on what is your focus? What it is for? Yeah.
You mean the cap theorem? Of course, distributed system, if rephrase it, I think about the cap theorem as like a marketing slogan. We focus all of this, but of course, the whole distributed databases struggle due to we have distributed data, and the required use algorithm based on something about MapReduce.
As we can remember from the slides, in case of network splits, some nodes became read-only. Is this correct?
It touched of our transaction algorithm. Of course, they became read-only, but I don't want to describe it now. It all depends of transactional algorithm, because you know, RAFT not allowed to process an data request in the node that's split it of the main part of the cluster. And in bounded of this presentation, we can't process any loads on splitted nodes.
Yeah, but talking the familiar language, can we say that we just sacrifice a little bit availability in the sake of consistency? A little bit of availability. Just can't write, only read. A little small sacrifice.
It all depends of other parts of Apache Ignite. I can describe it, but it's a long talk. We can create a database.
A good topic for our discussion area.
Okay.
Please, next question.
Okay, so you mentioned replication lag. How do you measure it, and why is it an issue?
Measure it, replication in a new version.
Replication lag.
Replication lag.
I thought it. Replication lag.
How do you measure it?
No problem. I understand your question, but we can't measure. It's not required, because all provided by the RAFT protocol here. It has an index, is a log index, and it used for like not the measure, but all the requests for read replication through the leader. And when we process the request from the logged node, the request will go the leader read index and return to the logged node in bound of RAFT algorithm. And when we when we talk about Apache Ignite like a whole product, entire product, it have another one approach. It has time on different local time for the all partition. We can't read from the logged replica logged data. All reads will be consistency. Is it the answer?
So you prefer consistency?
Strict consistency reading in the Apache Ignite, because you think about a different system, which one system have eventual consistency, and think about logged, but Apache Ignite in this way, and current implementation in the 3 have no way to read inconsistency data.
So talking about cap theorem, you highly prefer to be consistent when available. really prefer to be consistent. Okay, do we have one more question to challenge for our special prize? Please, more questions better.
Last question, it's what about partition storm? When we significant change topology, we have recalculate of much of affinity function. So do you have ability to throttle partition moving?
Of course, have. How we resolve this issue? We not change each time when the topology is changed. We don't recalculate. We try to avoid recalculation each time. We will recalculate after the some interval. The interval is determined by the configuration of the node. For the more that we will reconfigure the parameter for each data area. The data area is the area for stored particular table, part of table. And of course, yes, it is a problem. But you should understand, distributed database unfortunately cannot be work in this network perfectly. When we always have different topology. It depends on the distributed algorithm.
I see lots of interesting topics to discuss in our discussion zones. For now, please, a round of applause for our speaker. And a special challenging task for you to choose the best answer, the best question. Please, which one is the best?
Honestly, the best question was the latest one, which asked by the
Please come to the stage, and for our speaker, please officially give this prize. So, one more round of applause. Don't run away. Please don't run away. Take the prize. Thank you for asking. Now, you can take the speaker to our discussion zone, as always, where you can discuss all the things in private about release dates, how GridGain makes money from this, and so on. Thank you, and I will wait for you in a short time for the next talk.